All right, so quadratic properties. There are some things I'm gonna kind of probably breeze over and go touch back base after Thanksgiving, after spring break, okay? So, but we're just kind of gonna do just like the intro today. So this is kind of like all the information you're gonna get to know today. This is like it, okay? But you're not writing all this down. We're gonna go through each part individually, okay? So just a reminder, for quadratic equations, the graph, the line that it forms is called a parabola. Parabola. Or if you want to call it a parabola, I don't care, but it's called a parabola. Okay? And we're going to learn how manipulating the equation will change our parabola. You can have an up-facing parabola, you can have a down-facing parabola. Depending on which type of parabola it is, you can have a minimum or a maximum on your graph. Let's look at feature uno. Okay, let's talk about domain and let's talk about range. Okay, that's something you're going to see all year long with each type of functions that we're looking at. So domain, which value was the domain values? X values, beautiful. So that means our range values were Y. So for domain, we're looking for the leftmost point to the rightmost point. And for range, we're looking for the bottommost point to the topmost point. So looking at this graph right here, this is called the parent function. Parent function, where y equals x squared is the equation. This is a parent function for quadratics. This is, yes, I would. This is the parent function for quadratics. In this graph, you should notice it goes through the origin. So it has a point of 0, 0. And then from there, you see the features. So if I was looking at the domain of this graph, the leftmost point is an arrow. This tells me it goes on forever to the left. And then the rightmost point is another arrow telling me it goes on forever to the right. So what would the domain be?
All real numbers.
Perfect. X is all real numbers. But if I was looking at the range, the bottommost point would be what? 0. The Y value would be 0. And the topmost point, well, these arrows are telling me it's going to go on forever upwards. So what would you say the range would be?
No.
0.
Say it again, Brandon. All real numbers above 0. So what I can say is it's y is greater than or equal to 0, because everything above the 0, including the 0, goes through that point. It's that equation. So what you're going to notice, anything that we do, like if this said y equals x squared plus 3x plus 10, well, that's going to change from the parent function. And we're going to see how that looks different than the original parent function. It's just like with linear equations. I never called it this, but like this equation right here, y equals x, was the parent function where it had a slope of 1 and a y-intercept of 0. And anything we did different to it was a transformation from the parent function. I would.
Wait, what is the symbol between the X and the R?
It's all real number. All it means all. I don't know. I don't know the technical term for it. I would have to look it up. But it's just X is all real numbers. But it looks like an E. Exur.
I thought that it was maybe like an error or something else.
Oh, sorry. Yeah, it looks like an E. All right, may I move on? All right.
Are we doing a little activity?
We're not doing anything like homework wise now.
Well, I mean, like in the pod.
There's going to be like drawlets and polls, but that's the only thing. There's not going to be like a quiz at the end or anything like that.
So nothing's graded there.
The only thing that's graded is the writing assignment today.
By the way, I finished.
Okay, awesome.
Are you like grading that? Like reading it?
I'm reading it, and as long as you answered the prompt, you're fine. If you talked about anime the whole time, then to see if I actually was going to pay attention, then you'll probably just get 0. All right.
Like half of my
What?
Like half of my
Okay. All right. So let's look at this. Draw it. And we want to know which of the graphs have a domain of all real numbers greater than or equal to -7, but less than 2. So I want you to look at each graph. Yeah. And you're looking at the domain. So you're looking from left to right. That has a domain of all real numbers greater than or equal to -7, but less than 2. Domain. So everyone get an idea in your head which one you think that is. You can circle it and submit it once you do. Everyone have a pretty good idea? Should I just call on someone random? You chose what? All right. So, well, okay, let's say, what's wrong with A? Where does the domain start?
It
starts at -2, so that's why A is not right. C, no, what did they do on C to try to trick you?
The little dip is like right there.
The range is -7 and +2. So they try to trick you by using the range, having the same exact range as domain. So C's wrong. B's wrong, same thing. And then D, it starts at -7. It's equal to because it's a closed circle. And it's -2, and it's not equal to because it's an open circle. So D, good job, guys. Okay, my suggestion, anytime you have domain questions, take your time. Annotate the graphs. All right, cool. That's a star question, by the way. All right, so what we're going to start learning are different types of quadratic functions. So it can be in standard form, which you've already learned is y equals ax squared plus bx plus c. But what we're going to learn is vertex form. And that is y equals a times x minus h squared plus k. Y equals a, I know, x minus h squared plus k. Yes, I know. That's like, what? H and k? What? Y equals a times x minus h squared plus k. And if you notice, you've actually already seen this when we were simplifying quadratics, where I was like, okay, what do we do first? Box method that thing, then distribute, then combine like terms. Okay, so we've already seen this. You just didn't know that that's called a vertex form. Okay. In this vertex form, h and k hold very special values. Okay. In vertex form, h and k hold very special values. And you'll learn what a vertex is in a moment. We're going to learn what the axis of symmetry is. which has to do with H. The axis of symmetry is always X equals H. We're gonna learn about what a maximum and minimum is.
It's got way more confusion than I already was. And I don't even know how that's possible.
Don't worry, we haven't really, the only thing that we've learned right now is domain and range. The only thing, which was just review. We're gonna talk about the y-intercept, which you already know that is. And then the vertex. Now, again, we're gonna go deeper into this after spring break. What we're really looking at are looking at graphs, and we need to be able to identify certain things on a graph. That's all we're gonna do today. We're not gonna go extra deep today. Yes, that's the only reason I would have made this wait until after the quarter test, but they're making it on the quarter test, so I'm gonna have to just dibble in it just a little bit. Okay, so you don't actually need to write much from the slide down. Okay, so domain and range, and now we're gonna look at a couple of features on graphs. Okay, let's look at this beautiful graph right here. My suggestion is you could mark up take a screenshot, mark up your own graph, and save it to your notes. Technically, I usually give out notes every year for this, but I forgot to print them out. So, okay, all right. So looking at this graph, we want to talk about the zeros first. What's another word for zero? Solution. Another word? X-intercept. Another word? Roots. So on this graph, someone on Zoom, can you tell me the x-intercepts, please?
-2 and 4.
Beautiful. Thank you. Your boy, Alex. So x equals -2 and x equals +4. Okay, so that's a feature you're going to have to know how to find, the x-intercepts. Grayson, can you tell me the y-intercept, please? What? Look really closely. Yes, okay. All right, so the y-intercept is at -8. All right. Now, here's where people mess up. I ask you the domain. Some people would say it's from -2 to +4 because they look at the x-intercepts and then they stop. But doesn't the graph go beyond the x-intercepts? So what would the domain be for this graph? All real numbers. X is all real numbers. Because it's going to go forever and ever. These should be really arrows here to the left and the right. The issue is people see the x-intercepts and just thinks it stops, and that's what the domain is. But it doesn't stop at the x-intercepts. It keeps going forever and ever in the left and the right for eternity, okay? Look at the range. Don't say it out loud. Everyone get an idea what you believe the range is. Okay. Grayson, go ahead.
All numbers that are above -9.
Perfect. Because this bottom point right here is at -9. I'll just go ahead and write the point. It's 1, -9. Okay, so that lowest value on the graph is -9. So this will be y is everything greater than or equal to -9. Greater than or equal to because it's everything greater than or equal to -9. It's not less than -9. -9 is the lowest point. So if 1, -9 is my lowest point on this graph, do you think I would call that a maximum or do you think I would call that a minimum? It's called a minimum. Yes. Okay. This is called the minimum. And this is saying it, y'all making me feel weird saying it. Minimum. Okay. This is the lowest point on the graph. This is called our minimum. So when we have a parabola that is facing, or we call it it's facing upward, it's like a smiley face, this graph would have a minimum. And the minimum is at 1, -9. But really, when it asks for the minimum, it's usually just asking for the y value. So I have the minimum at -9. This point is also called the vertex. This point is also called the vertex. So there's like a lot of vocabulary hitting you all at once, okay? So the minimum on this graph is also called the vertex. So the vertex is the actual point, 1, -9, and the maximum is the actual y value, which would be y equals -9. There is one last feature you need to know about this graph. One more thing, okay? Let me pause though. Everyone feel good about domain?
Yes.
Range?
No, I have a question.
Yes.
So we're looking for the x-intercept. Why are we calling it beyond x?
If we're calling it what, baby?
We're looking for the x-intercept, right? So why is it on the?
No, this is domain.
No, I meant.
Huh?
So like, let's go back to domain. If we're looking for the x-intercept, why is it on the?
We're not looking for the x-intercept. I was saying that people think when I say what's the domain of a quadratic, they're like, oh, let me just write the x-intercepts down. That has nothing to do, unless it stopped at the x-intercepts, those are not the domain. The domain goes beyond our x-intercepts. What I was saying is that people get confused and say, oh no, my domain should be -2 is less than or equal to x is less than or equal to 4. But that's not true because it goes beyond those points. So that's not the domain. Okay. Everyone good with finding zeros?
Yes.
Okay, everyone understand
Wait,
this?
so what is
Mike?
the definition of vertex?
Vertex is the minimum or the maximum of a graph. So the vertex is the minimum or the maximum of a graph.
Oh, okay, thank you.
This graph has a minimum. So at the minimum is -9. The y value is -9. The vertex is the actual point of the minimum, and that would be 1, -9. That's the x and y value. And the last feature we need to know is the axis of symmetry. Axis of symmetry. Axis of symmetry. So look at what I'm doing so you make sure you get this when I do this, okay? The axis of symmetry is the vertical line that goes through the vertex. So if I was to make my axis of symmetry, it's the vertical line that goes through the vertex. And if this is a vertical line, is it an x equals equation or a y equals equation?
Y.
An x equals equation?
It's why for a reason. I was just thinking.
Yes, Bucks. Vertical undefined x equals equation. This is an x equals equation. So what is the x value of the vertex? 1. So the axis of symmetry would be x equals 1. This is the axis of symmetry is called, what does symmetry mean?
Same on both sides.
It's the same on both sides of the line. So if I was to fold the parabola from the axis of symmetry, it would be perfectly go on top of each other. So it's basically cutting the parabola in half. So if you notice, for example, you do not have to write this on your paper. If I looked at the x-intercepts, if this x-intercept is 1, 2, 3 away from the axis of symmetry this way, the other x-intercept should be the same, 3 away. 1, 2, 3 away from this part of the axis of symmetry. So the axis of symmetry cuts my parabola in half. In half.
Oh, so it's like the big old point.
Yes, yes.
Would it be possible to define symmetry?
No, not for quadratics. Maybe for a different type of, well, it wouldn't be a function because if it was on the side like this, then it would be not a function. Yeah. Okay, these are all the facts I need you to know for today. So I'm about to move on because we have literally 5 minutes, okay? I need questions though if you do have any. Okay, let's look at this graph. I want you to go ahead. Hold on, let me see what else is left here. Okay. Okay, so I want you to look at this graph. I want you to find the same exact features we found in the other graph. And then I guess we'll probably leave it there. So I want you to find the domain, find the range, find the zeros, 1240. Find the axis of symmetry.
So are those arrows right there? Like at the
Yes.
bottom?
Yes. Find the vertex. And would this one have a maximum or would it have a minimum?
A maximum.
It's a maximum. It has a highest point, the highest point. And find the maximum. So go ahead and find these features. I'm going to give you 2 minutes.
Are we supposed to be able to write on the slide?
No, you can take a screenshot of it and annotate it from there, from your photos.
Okay.
Yes, baby. Yeah. All right, about 30 more seconds. I know you probably won't finish in that time, but here, 30 more seconds. Okay, so go ahead and just tell me as we go, even if you're still working. What's the domain? X is all real numbers. What's the range? Y is less than or equal to what? 4. What are the zeros?
4 equals X and 8 equals X.
So 4 and 8, X equals 4, X equals 8. Okay. What is the axis of symmetry?
X equals 6.
X equals 6. What is the vertex?
4.
Give me the point.
4.
6, 4. So the X comes first, then the Y and a point. And then that means the maximum would be Y equals 4. These are the features I need you to know when looking at a quadratic equation. We'll have to go over a little bit more of this next time I see you or virtually see you. But other than that, do we feel confident with looking at a graph and identifying these features? Yes? If you don't, I need you to ask a question. Okay, awesome. Well, then I hope you have a fantastic 3-day weekend.